Hello students, welcome to Short Sir classes. So in this particular video we'll be solving this question from AP Calculus and AB exam. Okay, so here we're solving the question of this part A. So where there are number of 30 number of questions with a time duration of 1 hour. So let's move to the question number 21. For question number 20, it is saying that for any real number x, limit h tends to 0, so it is given sine of 2 of x plus h minus sine of 2x by h. So you have to find this value of this particular limit. So this topic is defining the derivative of a function, derivative of okay, is defining the derivative of a function and using derivative notation. So the limit of this difference quotient is of the form, is you can see that over here. So it is given that, so let's write the expression. This limit h tends to 0 sine of 2 of x plus h minus sine 2x by h. So this is the expression is given. So this is of the form. Okay, so this is of the form where it is given as, we can write it as limit h tends to 0 f of x plus h minus f of h minus f of x minus f of x by h, right? So here f of x is given as sine of 2x, as given over here. You can see this is the f of x, right? So this is the one way to express the derivative of f. So from here, if we can write this by the chain rule, so we can write this as f prime x is equal to cos of 2x multiplied by 2. That is nothing but 2 of cos of 2x. So the correct option for in this case is option D for question number 21. So for the question number 22, it is given that shown above is a slope field for which of the following differential equations. So this slope field for which of the following differential equation out of the 4 options, we have to find the correct one. So this topic is already given, that is the sketching slope fields, right? So whatever the segments you can see, the segments in the slope field, the segments in the slope field suggest, point number 1, that the slopes depend only on the variable y. Only on the variable y. This is point number 1. Now point number 2, the slopes are non-negative. This is the point number 2. And point number 3, the slopes are 0. When y equal to 0, right? So if we check with these options, the first option A, this option A is given that dy dx is given as mod of x plus y. So when this is given, this differential equation, it does not satisfy the condition 1 and 3. Does not satisfy the condition. So this is not true. So if we check with the option B, that is dy dx is equal to nothing but x cube. So this does not satisfy any of the condition. 1, 2 or 3 does not satisfy any of the condition. Again, next option, this C, that is dy dx is equal to y cube. This does not satisfy the condition 2 when y is less than 0, right? So this will not satisfy the condition. Only if you go with the option 4, that is option D, so option D is given as dy dx is equal to y square, and this differential equation satisfy all the three conditions, that is slope depends on the variable y, slopes are non-negative, and slopes are 0 when y equal to 0. So the correct option for question number 22 is option D. This question number 23 is saying that the base of a solid is the region in the first quadrant bounded by the y-axis, the x-axis, and the graph of y equal to e to the power x, and the vertical line x equal to 1. For this solid, each cross section perpendicular to the x-axis is a square. Then we have to find the volume of the solid. So this topic is from volumes with cross section squares and rectangles. Okay. Now let us see how to solve this problem. Okay. We know that the area of a square of side length s is nothing but a square, right? So a typical cross section, if we write this, that typical cross section of the solid is a square with side from the x-axis, right? Side from the x-axis to the graph of y equal to e to the power x, right? So the length of the side of the square, it will be therefore s equal to e to the power x. This will be the length of the side of the square. So area of the square, so this area of the square, what will be the area? So area of the square is therefore e to the power x square is equal to e to the power 2x, right? Then the volume of the solid is found by using the definite integral of the cross-sectional area. So from here you can find the volume. So volume you can get from the definite integral using the definite integral of the cross-sectional area. Right? So what it will be, if we write this, it will be 0 to 1 e to the power 2x dx, right? So it is simply 1 by 2 e to the power 2x is 1 to 0. So from here you can write this, it will be 1 by 2 e square minus half. So which one is the correct option? Here you can see that the option B is the correct one for question number 23. Half e square minus half. So this question number 24 is saying that the graph of the piecewise linear function f. So this is the graph of f is shown above. So to find the value of this integral 0 to 12 f prime of x dx. So from this graph we have to determine that. So this topic is from the fundamental theorem of calculus and definite integrals. So you can write it as d of I, right? So from the fundamental theorem of calculus, we can get this 0 to 12 f of prime x dx, f of prime x dx. So we have to find this. You can find that f of 12 minus f of 0. So f of 12, you can see that it is nothing but minus 4, right? So from here you can get this is minus 4. So f of 12 is the function of f of x, that is y, and it is also minus 4. So which is going to be as coming as minus 8. So where the values of f at x equal to 0 and x equal to 12 are obtained from this curve. Okay, so this correct option for our case will be this minus 8, the option A for question number 24. Question number 25 is saying that the equation y is equal to 2 into e to the power 6x minus 5 is a particular solution to which of the following differential equations? Out of the 4 options, you have to find the correct one. So this topic is from the verifying solutions for differential equations. Right? So verifying solutions for differential equations. Okay. Now, so the thing is that one way to verify a function is a solution to a differential equation is to check that the function and its derivatives satisfy the differential equation. So this is one of the way to verify. Satisfy the differential equation, right? So the differential equation in this option involves this. If we go through this particular option A, so it involves y and y prime, right? So the correct derivative must be computed and the algebra correctly done to verify that the differential equation is satisfied. So we have this y prime. So from here we can, the equation is given that it is nothing but y equal to 2 e to the power 6x minus 5. So from here we can easily calculate the y prime equal to will be 12 e to the power 6x, right? So if we check with this option A, so where it is given this y prime minus of 6y minus 30. So if we do this value of this 12 of e to the power 6x minus 6 of 6 equal to, it is given as y, you will value the put the value of y over here. So it is nothing but 2 to the power 2 into e to the power 6x minus 5 minus 30. So if we simplify this, it will equal to 0 only, right? So for this option, the option is stands correct for question number 25. Now if we see the option B, this 2y prime minus 12y plus 5, if we go through this, so this will be incorrect because the correct derivative was found, and but the differential equation will appear to satisfy if 12 in the second term, okay, is not distributed correctly across the two terms in the parenthesis. So similarly, this option B, C, D, this C and D will also be incorrect, leaving the option A, which is the correct one as shown in this solution. So for question number 25, our correct solution is option A.